What's up, guys? Last year in Algebra 2 and in Geometry, you will have had the opportunity to do with right triangle trig, which is the idea of, in a triangle that you know is right, if you have as few as even just two other pieces of information, you can still find every other thing that is listed on the triangle. And so you should feel pretty comfortable with this, but if you don't, here's a quick review. So I've got this one angle, 40 degrees, and that is enough for me to be able to set up some sort of ratio. So if I wanted to find one of these missing sides, it'd be pretty easy. I know that the sine of 40 degrees is equal to, sine is opposite over hypotenuse, so op over hypotenuse. And then the process from here is as simple as just like replacing each thing with what we see from the triangle and then doing some basic algebra to solve it. So if I type in the sine of 40 degrees into a calculator or into a Google calculator, it'll give me 0.64278, so I'll round that up to 8, is equal to the opposite side here. Well, opposite of 40 degrees was just the variable a, and then the hypotenuse is listed as 12. So I now know that I could solve for a if I have 0.6428, and a is divided by 12. Some basic algebra tells me I could multiply both sides by 12. So a should be equal to 12 times this decimal, 0.6428. So in my calculator, I'm going to multiply that by 12. And I get that a is about equal to 7.71. 7.71, which makes sense. Like 7.71, this looks a little bit shorter than 12, so that's like a reasonable distance. If I got something crazy like 70, that wouldn't make any sense. Or if I got something ridiculous like, I don't know, 0.02, like that also wouldn't make sense because this side needs to be reasonably in the neighborhood of 12. So that's how I find my missing side. Now there's actually more information that I can find from here once I have that. So I know that this is supposed to be 7.71. So I'm going to do something a little bit crazier here and say that if I'm missing an angle, like if I want to find what angle B is up in here, that's also something I can do. B, this is the adjacent of B, this is the hypotenuse of B. So the tangent of B would be equal to, actually let's not use tangent, let's use cosine. Don't be dumb, Mr. Olson, don't be dumb. Sorry. Cosine of B would be the adjacent, so 7.71 over the hypotenuse, which would be 12. If I do that on my calculator, 7.71 divided by 12, I get 0.6425. It's starting to look familiar, and I'm recognizing why that is, but I'll just play this out anyway. So if I know that the cosine of B is 0.6425, then what I can do is I can take the arc cosine of this thing, and it should give me an angle that B could be. So what is the inverse cosine, the arc cosine of 0.6425? Well, if I use my calculator for that, second cosine 0.6425, I end up getting 50.02, which actually, duh, like of course it's that, because I could have used a totally different way of finding that missing angle. I could have looked at this and said, oh, duh, 90 minus 40 will give me 50. But this is great for if you don't have any of the angles. You can actually jump right into this and find your missing angles from the get-go. You just need to be really comfortable solving the trig ratios as they are. And so I'll throw some practice problems out for you to work with and an exit ticket for you to check your own mastery on.